Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes. We're traveling to the moon's hidden side. From its ancient formation to its shadowed mountains, from whispered legends to the quiet science that reveals its mysteries, we'll explore 100 sleepy facts to help you relax, unwind, and dream of the cosmos. And if these calm explorations help you rest, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes and let's begin. Fact 1. The cloud that became our moon. Long before the moon ever glowed in our night sky, there was only a drifting cloud of dust and gas, a quiet haze circling the young Earth. In that gentle cosmic dusk, tiny grains floated weightlessly, stirred only by the soft pull of gravity. Over time, those grains began to gather, touching, clinging, and folding into one another, like snowflakes settling in slow motion. Scientists believe this cloud may have come from a great collision, but in its earliest calm, it behaved like a lullaby in space, a cradle forming from scattered light. What began as a shimmering mist would one day become the companion we know so well. And from that peaceful haze, the first stirrings of the moon began to whisper into being, leading softly to the moment of impact that shaped its destiny. Fact 2. A collision in slow motion. Long ago, when Earth was still molten and new, a Mars-sized world called Theia is thought to have brushed against it. Not a violent shatter as we imagine, but a cosmic meeting stretched across hours, unfolding with the slow inevitability of tides. In the silence of early space, the two bodies merged and scattered, their outer layers lifting into orbit as glowing ribbons of rock. Those ribbons cooled and curled around Earth like a ring of embers. Over time, they thickened, clumped, and softened into a single growing sphere. The moon was not born in an instant. It drifted into shape, gathering itself with patience, like a lantern forming from drifting sparks. And as it cooled, it prepared for its first true glow, the early light that would shine across an infant Earth. Fact 3. The birth of lunar light. When the moon first emerged as a solid world, it did not look pale or gentle. It shone red-hot, wrapped in the soft radiance of cooling stone. The entire surface shimmered with heat, glowing like a quiet ember suspended in the dark. This newborn moon cast a faint, warm hue on the oceans of early Earth, painting the night with colors we can only imagine now. Its surface churned with molten rock, but above it hung a peaceful stillness, no air, no wind, only the slow release of heat into the vast emptiness. As millions of years passed, that glow faded, settling into the soft silver we know today. And as the moon cooled, its crust began to form, setting the stage for the landscapes that would one day hide a mysterious far side. Fact 4. When the moon glowed like fire. In its earliest days, the moon was still wrapped in a molten shell, radiating warmth into the cold of space. Imagine a world that shimmered like a slow-burning coal, not bright enough to dazzle, but glowing with a quiet living heat. Rivers of magma drifted across its surface, shifting with a gentle, liquid grace. There was no sound, no wind, only the steady cooling of a young celestial body learning how to become solid. From Earth, this fiery moon would have looked almost alive, pulsing softly in the sky, like a warm heartbeat. And as it continued to cool, that molten sea began to settle, preparing to harden into its first true crust. Fact 5. The oceans of magma. After the great impact that formed it, the moon was covered in vast molten oceans stretching across nearly its entire surface. These magma seas moved slowly, thicker than honey, glimmering beneath the quiet starlight. As the moon lost heat to space, crystals of lighter minerals floated upward, forming a delicate layer atop the molten world. Bit by bit, these minerals gathered and grew, eventually weaving together into a fragile crust. This early crust was thin in some places, thicker in others, shaped entirely by how the molten ocean cooled beneath it. Those differences, formed in deep time, would one day explain why the far side became so rugged and towering. But in these earliest moments, the moon was simply drifting toward stillness, its fiery seas beginning to freeze into stone. And as those seas hardened, the moon's first true surface quietly emerged beneath the stars. Fact 6. The first crust forms. As the magma oceans cooled, a pale rocky shell formed across the moon's surface, the first skin of a world learning to rest. This crust, made mostly of a mineral called anorthosite, reflected sunlight with a soft, pearly brightness. Even today, pieces of it remain in the lunar highlands, shining faintly like frozen dawn. But in its youth, this crust was fragile, easily cracked by the constant rain of space debris that drifted through the early solar system. Each impact helped shape the moon we know now, carving valleys, raising mountains, and deepening shadows. The far side, wrapped in thicker crust, resisted change differently, building the rugged, dramatic terrain that would stay hidden from Earth for billions of years. And with that first fragile crust in place, the moon's earliest face began to take shape, soon to be sculpted by the quiet storm of impacts that followed. Fact 7. The moon's earliest faces. With its first crust formed, the moon began to wear the earliest versions of its many faces. But these faces were nothing like the one we know today. They were smoother, less defined, painted mostly in pale mineral tones. Over time, shifting pools of molten rock welled up beneath the surface, breaking through in some places and leaving others untouched. Each quiet eruption subtly reshaped the landscape, adding layers, sealing older scars, and creating the first hints of the highlands that would come to dominate the far side. Imagine a world still in motion, not fast or chaotic, but slowly adjusting, settling, and cooling like a piece of pottery gradually finding its shape. These earliest faces would be erased by the storms of debris to come. But for a gentle moment in the moon's past, they shone softly beneath the newborn sun. And soon, the sky above it would fill with a silent rain of stones and ice. Fact 8. The ancient rain of impacts. In the moon's youth, the solar system was a place of drifting fragments, pieces of old collisions, icy specks from distant orbits, and rocky wanderers moving through the void. The moon, small and newly formed, had no atmosphere to shield it. So every grain, pebble, and mountain-sized fragment that crossed its path arrived unfiltered, touching the surface with a silence deeper than any on Earth. Some impacts were gentle taps, leaving faint impressions. Others carved enormous basins, throwing shimmering clouds of dust into the sky that settled slowly back onto the surface. Each strike reshaped the crust, mixing minerals, melting rock, and layering history into the ground one imprint at a time. Over millions of years, This rain of impacts sculpted both sides of the moon, but the far side, wrapped in thicker crust, responded differently, growing more rugged with each silent blow. Even today, those ancient scars remain untouched. And as the impacts continued, the moon slowly began drifting away from Earth, changing their dance forever. Fact 9. A surface shaped by silence. Because the moon has no air, no wind, and no flowing water, every feature carved into its surface remains almost perfectly preserved. Craters from billions of years ago still sit as crisp and sharp as the night they formed. Dust from ancient impacts has never been blown away. On the hidden far side, this stillness is even deeper. Shielded from Earth, untouched by radio noise and marked only by time. The surface became a canvas where silence itself left a record. Tiny glass beads formed from molten spray glisten faintly in the sunlight. Sharp ridges stand where they first rose. Shadows lie exactly where they did in ages past. And in that stillness, the moon's steady drift away from Earth continued, setting the stage for the tidal lock that would keep one side forever turned from our view. Fact 10. How the moon began to drift away. In the quiet of deep time, the moon did something subtle and patient. It started drifting. When it first formed, it circled much closer to Earth, appearing enormous in the sky, so large it would have filled early horizons with a gentle, glowing presence. But gravity has its own slow rhythm, and the tides it stirred in Earth's young oceans pushed back on the moon with each passing day. This tiny nudge, repeated over millions of years, encouraged the moon to step outward, little by little. Even now, it continues to drift away at a pace so slow we never notice, about the width of a fingernail each year. As it moved, its rotation gradually slowed, aligning its pace with its path around Earth. And this quiet dance set the stage for one of the moon's most mysterious features, the hidden far side we never see. Fact 11. The gentle locking of tides. Tidal locking sounds dramatic, but in truth, it is one of the universe's softest, slowest transformations. As the moon drifted outward, the pull between Earth's gravity and the moon's rotation formed a delicate balance. Gradually, the moon turned more slowly until one side faced Earth for longer than the other. Over millions of years, it settled into a perfect rhythm, one rotation for every orbit. No sudden shift, no cosmic jolt, just a gentle synchronization, like two dancers gradually falling into step. Because of this, the moon now keeps the same face turned toward Earth, always showing us its familiar features, while its far side remains softly tucked away. This quiet locking shaped everything we know about the moon's appearance, and everything we long to discover about its hidden hemisphere. And within that locked embrace, a mystery unfolded, a world where Earth never rises. Fact 12. The rhythm that keeps one face. Turned. Once tidal locking was complete, the moon began its steady, hypnotic rhythm, turning exactly once as it completes a full orbit around Earth. Because of this, from our perspective, the same features look back at us night after night. Bright highlands, dark seas, and the smudged patterns we've studied for centuries. But on the far side, the experience is entirely different. Earth never appears in the sky. Its light never spills across the landscape. Instead, the sun alone paints the terrain, rising slowly, setting slowly, in long, lingering arcs. This rhythm is so stable that the far side has stayed hidden for billions of years, waiting patiently for spacecraft to reveal its rugged beauty. And beyond that quiet rotation lies the beginning of the far side's unique, and fascinating identity. Fact 13. How the far side became the hidden side. Because the moon turns only once each time it circles Earth, half of it is forever turned away from our view. This far side isn't darker, harsher, or more mysterious by nature. It simply rests in a position we can never see from the ground. Over billions of years, this orientation has stayed steady, like a quiet face turned toward the cosmos. The near side grew familiar to us, touched by human stories and telescopes, while the far side remained untouched by Earth's gaze. There's a gentle poetry in that stillness, an entire hemisphere living in privacy, shaped by sunlight we never witness. Its hidden landscapes are not secrets by intention, but by geometry, by rhythm, by the peaceful balance between two worlds. And in that hidden half, a strange truth emerges, a world where Earth never rises. Fact 14. A world without Earthrise. On the near side of the moon, Earth hangs in the sky like a brilliant jewel, always hovering in roughly the same place. But on the far side, the sky is profoundly different. Here, Earth never peeks over the horizon, never paints the land with its pale blue glow, never swells or shrinks with phases. The far side knows the sun, the stars, and the long lunar day, but it never knows Earth. Imagine standing on that silent landscape, watching a sky that feels both familiar and alien. The stars would seem sharper without atmospheric blur, and the sun would rise and set with the steady rhythm of a 29-day cycle. But Earth, our home, would never appear. It would simply be absent, wrapped behind the horizon forever. This absence shapes the mood of the far side, quiet, solitary, and deeply still. And in that stillness, something beautiful happens. The darkness itself begins to glow. Fact 15. The darkness that isn't dark. Although we often imagine the moon's hidden side as a place of deep shadow, the far side is not truly darker than the near side. It receives the same amount of sunlight, warming slowly through its long day and cooling gently through its long night. What it lacks is earthshine, the soft, reflective glow that brightens the near side even when the sun sleeps. Without that gentle blue light, the far side's nights feel deeper, softer, more muted. In that muted glow, shadows stretch farther, and the terrain feels almost dreamlike. Craters appear more defined in the low angles of morning light. Ridges glow gently as the sun brushes their rims. Nothing is harsh. Everything is slow, quiet, and serene. And as the far side waits for each dawn, it reveals another truth. Its landscapes are shaped differently, carved in ways earthbound eyes never expected. Fact 16. The far side's endless stillness. The far side of the moon is a place where stillness feels almost physical, as though it settles gently on every stone and ridge. Without the glow of earthshine, and without the constant gaze of our telescopes, this hemisphere has existed in a kind of cosmic solitude for billions of years. Its quiet is deeper than any silence on Earth, untouched by wind, water, or life. Every grain of dust lies exactly where it has fallen. Every crater rim stands unmoved, and every shadow lingers patiently through the long lunar night. If one could stand there, they might feel as though time itself had slowed, stretching softly across the landscape. The far side does not rush. It does not change quickly. It simply waits, holding its ancient shapes with gentle persistence, and hidden within that stillness is a subtle beauty, the way light drapes itself across terrain that no human once saw. Fact 17. The viewing angle. From Earth, we never see more than about 59% of the moon's surface. Lunar libration, a tiny wobble as the moon moves along its orbit, lets us peek just beyond the edges, but never truly glimpse the far side. This slight swaying is part of the moon's natural rhythm, caused by its elliptical path and uneven speed. At certain times, we see a little farther east or west, sometimes a touch farther north or south, but the far side always remains just out of reach. Early astronomers suspected another face might exist, but could only imagine its features. It wasn't until spacecraft circled the moon in the 20th century that humanity finally saw the far side's rugged, unfamiliar terrain. This gentle wobble reminds us that even in what seems constant, small motions reveal hidden truths. And beyond that subtle dance lies the surprise of how different the two hemispheres truly are. Fact 18. Why the hidden side looks so different. One of the moon's greatest puzzles is how dramatically the far side differs from the near side. While the near side wears wide, dark plains of ancient lava, our familiar Maria, the far side holds almost none. Instead, it rises in pale, mountainous highlands, marked by countless craters. Scientists believe the far side's crust became much thicker during the moon's early cooling, making it harder for lava to break through and spread. Without those volcanic floods, the far side kept its rugged, ancient face almost entirely intact. This contrast feels like two worlds sharing one body, one shaped by flowing seas of rock, the other carved mainly by impacts and time. Each hemisphere holds its own quiet story, written in stone. And in those rugged highlands, the far side reveals some of the most dramatic landscapes the moon has to offer. Fact 19. The far side's deeper craters. Across the moon's far side, craters stretch deeper and wider than many found on the near side. The thicker crust beneath them resisted melting and filling, allowing impacts to carve valleys with sharper walls and deeper floors. Some of these craters drop farther below the lunar average than any basin the near side holds, forming long, quiet shadows that linger for days at a time. Because there is no wind or erosion, their edges stay crisp, like ancient bowls carved from stone. Standing at the rim of one, you might look down into a darkness that feels almost liquid, so still and undisturbed it seems to pool at the center. Each crater is a window into the moon's oldest chapters, portals to moments when wandering fragments shaped a world forever hidden from Earth's eyes. And within these deep hollows, another mystery unfolds. The far side has no familiar seas. Fact 20. A land without familiar seas. The near side of the moon is decorated with broad, dark plains we call Maria, formed by ancient lava that once welled up from below. But on the far side, these seas are almost completely absent. Instead of wide, smooth fields, the land rises into rugged highlands, layered with fractures and crater rims. Scientists think the far side's thicker crust made it difficult for molten rock to break through, keeping its surface more pristine and untamed. Imagine walking across such a world. No expansive plains easing the horizon, no dark seas to break the pale terrain. Instead, the landscape rises and folds like a frozen ocean of stone. The absence of Maria is not emptiness. It is a presence of something older, untouched, and deeply serene. And beyond those highlands lies the quiet divide between the moon's two faces, where light behaves just a little differently. Fact 21. The lava seas. We know on the side we can see from Earth, the Maria form sweeping plains that stretch for hundreds of miles. They appear dark because iron-rich basalt, cooled into smooth, dense rock long after the moon's crust first solidified. These plains give the near side its familiar expression: the man in the moon, the shapes children trace with sleepy eyes on quiet nights. They are reminders of a more restless lunar past, when molten tides briefly reshaped vast regions. Yet these seas also highlight what the far side never experienced: the softening effect of flows that erase older scars. The near side's lava plains are younger, smoother, and more uniform than anything on the far side. And from this contrast emerges one of the moon's most poetic truths. Two hemispheres crafted by the same world, yet shaped by entirely different stories. Fact 22. The far side's missing oceans. While the near side's Maria form wide, tranquil plains, the far side has almost none of these dark volcanic surfaces. Instead, it stretches in pale, rugged expanses shaped by ancient highland material. This absence of lava seas puzzled scientists for decades. Why would two halves of the same world evolve so differently? In time, studies revealed a quiet truth. The far side's crust cooled into a thicker, more rigid shell, one that rarely allowed molten rock to rise. Without those lava floods, the far side kept its ancient scars, preserving the marks of its earliest impacts. In a way, the far side is like an untouched diary, its pages never overwritten by volcanic ink. It remains closer to the moon's original story. And with that untouched terrain comes the rise of a landmark distinction: a tale of two crusts. Fact 23. A tale of two crusts. The moon's near side and far side differ not only in appearance, but in structure. The crust beneath the near side is noticeably thinner, likely because heat-producing elements gathered there in the moon's early days, keeping the rock warmer and more fluid. The far side, bathed in fewer of these elements, cooled more quickly, forming a thick, resilient crust. This thicker shell resisted lava intrusion, meaning the far side never experienced the smoothing, filling, and reshaping that the near side did. Imagine two siblings formed from the same origin, but shaped by different temperatures. One softened and reworked, the other hardened and ancient. The result is a striking contrast: a near side written with broad, dark strokes, and a far side etched in fine, delicate detail. And that thicker crust helped build the towering highlands that define the far side's dramatic horizon. Fact 24. Why the far side is more rugged. Because the far side's crust grew thick and strong, every impact left its mark more deeply. Rather than melting into smooth plains or filling with lava, craters piled upon older craters, ridges rose along fracture lines, and tall mountains formed from uplifted blocks of ancient rock. The landscape became layered and complex, its features sharper, steeper, and more densely packed than the near side. Even small impacts carved crisp boundaries that remain nearly unchanged after billions of years. This ruggedness gives the far side a sense of age that feels almost tangible, as though each ridge carries the memory of a moment long past. Under the soft sweep of sunrise, those mountains glow like pale gold, their shadows stretching across valleys that haven't shifted since the moon's earliest days. And beyond those rugged highlands, sunlight begins to play along edges where light behaves differently, whispering toward the next chapter of the moon's hidden story. Fact 25. Ancient heat and cool shadows. In the moon's earliest days, trapped heat beneath the surface created gentle swells and quiet distortions in the crust. On the near side, this warmth lingered longer, allowing volcanic plains to emerge. But the far side cooled more quickly, settling into broad highlands and deep basins. Over time, the contrast between ancient warmth and early chill left its mark across the hidden hemisphere. The far side's cooler crust became rigid, resisting change even as impacts continued to shape it. As sunlight brushed across this ancient land, shadows gathered in every hollow, lingering longer and deepening the terrain's sense of timelessness. The stillness of these cool reaches carries a feeling of age so profound it almost seems to hum. And as these cold shadows settled, the far side's thick skin continued to grow, layer by patient layer. Fact 26. The far side's thicker skin. The thickness of the moon's crust isn't uniform, and the far side holds the most impressive stretch of it: dense, deep, and ancient. Scientists believe pockets of heat-producing elements accumulated more on the near side, leaving the far side with fewer internal sources of warmth. As a result, its crust hardened into an enduring shell that sometimes reaches over 50 kilometers thick. This reinforced layer acted like armor, protecting the far side from internal reshaping. Because of this thick crust, molten rock rarely rose to the surface. Instead, impacts piled upon impacts, compressing history into tightly packed layers of stone. The result is a surface that feels older, wiser, and more intricately textured than its near-side counterpart. In standing at the boundary between these worlds, one finds mountains that seem to lean gently into the sky. Fact 27. The mountains that rim the edge. Where the far side meets the near side, the moon lifts into striking chains of mountains, some of its tallest, most breathtaking formations. These ranges form the rims of vast ancient basins, pushed upward by colossal impacts billions of years ago. On the far side, the crust's extra strength allowed these rims to soar even higher, standing like quiet sentinels along the lunar horizon. In the soft light of lunar dawn, their peaks glow silver, while their valleys remain steeped in shadow. If you were to walk along one of these ridges, the world would seem both immense and delicate beneath the silence. Each step would echo across stone unchanged for ages, each shadow stretched thin in the long morning light. And beyond these mountainous rims, the illumination shifts again, reminding us that even sunlight behaves differently as it travels across the moon's hidden side. Fact 28. Where the light travels differently. On the far side of the moon, light behaves with a quiet subtlety that feels almost otherworldly. Because there are no wide volcanic plains to smooth the surface, sunlight arrives at sharper angles, slipping across ridges and valleys with delicate precision. At sunrise, the land glows only in narrow bands, each peak catching the first touch of warmth before the lower basins awaken. As the day slowly unfurls, shadows stretch like long, gentle strokes of ink across the pale terrain. The far side's roughness makes the light feel more textured, more layered, as though the sun's rays must weave around 1,000 small obstacles before illuminating the landscape. This dance of brightness and shade adds a certain dreamlike character to the hidden hemisphere. And beyond these shifting rays, the far side holds a deeper truth: two hemispheres shaped by different histories. Fact 29. Two hemispheres, two histories. Though born from the same great collision, the moon's near side and far side followed different paths through time. The near side remained active for longer, its thinner crust inviting ancient lava to rise and fill its wounds. The far side, hardened early, held onto the memory of every impact, preserving a terrain etched in fine detail. This duality creates the sense of two worlds sharing a single body, each shaped by the same forces, but responding to them in unique ways. Over billions of years, the near side's lava plains softened its features, while the far side's thick shell preserved its rugged heights. When scientists mapped both hemispheres, the difference was so striking it felt like uncovering a secret world hidden just beyond our sight. And between these contrasting realms lies a moment of balance, a long pause at lunar noon. Fact 30. The quiet divide at lunar noon. Lunar noon on the far side is unlike any noon on Earth. The sun rises slowly over nearly 2 weeks, climbs gently, and then rests high in the sky for days before beginning its long descent. At the peak of this journey, lunar noon, the landscape becomes almost motionless. Shadows shrink into thin outlines, and the rocks glow softly beneath the steady, unbroken light. Time feels stretched, as though the day itself has paused to breathe. This long, calm moment highlights the divide between the moon's two faces. On the far side, noon reveals every ridge, every crater, every untouched fragment of ancient history. It is a moment of quiet clarity, when the hidden hemisphere seems to exhale its age into the warm sunlight. And as that sunlight lingers, it begins to illuminate some of the far side's most remarkable landmarks, starting with a lonely, far-flung mare. Fact 31. Mare Moscoviense's Lonely Lake. Though the far side is nearly empty of seas, one rare exception lies cradled within ancient highlands. Mare Moscoviense. This small, dark basin rests like a quiet lake surrounded by pale mountains, forming one of the far side's most striking contrasts. Its smooth volcanic surface feels almost out of place in such a rugged world, as though a single drop of ink had settled onto a canvas of ivory stone. The lava that once filled this basin cooled into dark basalt, giving it a gentle, glassy sheen when sunlight glides across it. To early lunar imaginations, this lone mare suggested a secret oasis on the hidden hemisphere. Even today, it remains a soft whisper of the near side's volcanic past, tucked peacefully within vast highland terrain. And beyond this solitary lake lies something far grander, one of the largest impact scars in the entire solar system. Fact 32. The enormous South Pole Aitken Basin. Stretching nearly 2,500 kilometers across, the South Pole Aitken Basin is an immense ancient wound carved into the far side. It is so wide and so deep that if Earth had a comparable crater, it would span entire continents. Formed by a colossal impact more than 4 billion years ago, the basin dives into some of the moon's lowest elevations, revealing minerals rarely seen elsewhere. Standing at its edge, you would look across a horizon shaped by a single moment so powerful it helped define the moon's early history. And yet, the basin now rests in profound stillness, its violent origin softened by billions of years of quiet sunlight and drifting dust. Scientists consider it one of the most important landmarks on the moon, a window into layers normally hidden far beneath the surface. And rising from this vast depression are peaks that seem to reach for the sky. Fact 33. Peaks, taller than Everest, in their way. Along the rim of the South Pole Aitken Basin, massive mountains rise higher than almost any found on the near side. While not technically taller than Earth's Everest when measured from base to summit, these peaks soar above the surrounding terrain in dramatic relief. Some tower more than 8 kilometers above the basin floor, catching sunlight long before the valleys below. In the thin, airless silence, Their slopes shine like silver cliffs, untouched by erosion, frost, or storms. These highlands feel ancient and eternal, their edges crisp and unsoftened by time. If you could stand atop one, you'd witness a sweeping view of pale ridges, deep shadows, and the muted glow of far-off craters, an untouched world stretching in every direction. And beyond these towering heights, the far side spreads into sweeping highlands that hold some of the moon's oldest surviving terrain. Fact 34. The Far Side Highlands. The Far Side's highlands are among the oldest surfaces in the entire solar system, quilted with craters and ridges that have endured unchanged for billions of years. These pale, rugged expanses stretch across most of the hidden hemisphere, forming a world of elevated plateaus and steep valleys. Because no lava flows ever smoothed their contours, the highlands preserve the moon's earliest memories, like pages of a book that were never rewritten. Walking across them would feel like moving through time itself. Every step would land on dust older than the oldest fossils on Earth. Every horizon would be shaped by ancient impacts whose echoes have long since faded. In the soft sweep of lunar sunrise, the highlands glow like frosted silver, and deeper within these ancient lands lie hollows that plunge into some of the moon's greatest depths. Fact 35. The deepest known lunar depths. Within the far side's vast terrain lies a place that descends farther than any other point on the moon. The depths of the South Pole Aitken Basin. Here, the surface sinks more than 8 kilometers below the lunar average, reaching levels where minerals from deep within the moon's interior were pulled up and exposed. This extreme depression is thought to have been carved by one of the most powerful impacts the moon ever endured, a moment so immense it almost reshaped the entire hemisphere. Standing at the basin floor would feel like standing in a quiet, ancient bowl, carved from shadow and memory. The sun's rays would reach only at long angles, slipping across jagged slopes and catching the tops of distant ridges long before touching the valley itself. In this profound lowland, the silence feels even deeper, like a soft, eternal exhale. And rising from these depths are quiet valleys where darkness lingers long after sunrise. Fact 36. The hidden valleys of shadow. Across the far side's rugged terrain, there are valleys so deep and sharply carved that sunlight reaches them only briefly during each long lunar day. These hidden valleys lie tucked between steep ridges, their floors cooled by endless shadow. During the lunar dawn, soft light creeps slowly down their walls, illuminating the highest outcrops first, then gliding gently into the depths. But for much of the cycle, these places rest in a cool twilight of muted grays and soft blues. In such valleys, the temperature drops dramatically, creating some of the moon's coldest natural pockets outside the polar regions. Dust settles thickly here, forming layers as fine as powdered snow, untouched by wind or weather. They are sanctuaries of stillness, quiet, protected, and ancient. And beyond those shadowed valleys, the terrain shifts again into sweeping chains of craters that stretch across the far side like strings of cosmic pearls. Fact 37. The comet-shaped chains of craters. Across the far side, you can find long, graceful chains of craters that look almost like trails left by silent travelers in the dust. These formations, called catenae, often stretch for dozens of miles, each crater nearly touching the next. Scientists believe many of these chains were formed when a single incoming object, perhaps a fragmented comet or asteroid, broke apart just before striking the surface. Instead of one large impact, It's scattered gently across the land, leaving a dotted line of impressions, like footprints across a pale shoreline. Under low sunlight, these crater chains appear almost delicate. Their rims cast soft, repeating shadows, and their floors glow with a muted silver sheen. They hint at moments when the moon's hidden side received visitors from distant regions of space. And beyond these patterned traces lies a basin so large it nearly reshaped the moon itself. Fact 38. The basin that nearly broke the moon. Among the far side's many vast features, one of the most dramatic is the immense South Pole Aitken Impact Basin, a structure so enormous that some researchers believe it came close to altering the moon's internal structure. The impact that created it released unimaginable energy, sending shock waves rippling through the moon's mantle and crust. Yet over the ages, this colossal scar settled into silence, its once molten walls cooling into towering rims and deep valleys. Today, the basin still holds clues to the moon's early interior, containing minerals dredged up from layers normally hidden far below. It stands as a testament to both the violence of the moon's youth and the calm that followed, a place where once chaotic forces now rest beneath a thin layer of dust. And when you stand at its edge, the horizon rises sharply, offering a rugged boundary where the far side's jagged skyline begins. Fact 39. The far side's jagged horizon. From many places on the far side, the horizon looks sharper and more sculpted than on the near side. The abundance of craters, mountains, and uplifted ridges forms a skyline of irregular shapes. Peaks leaning into the sky, crater rims arching gently, and distant plateaus shining with pale light. At lunar dawn, these formations catch the first rays of sunlight, glowing soft gold while the rest of the surface remains in quiet shadow. Because there is no atmosphere, every line remains crisp, every silhouette sharply defined. The horizon doesn't fade or blur. It stands clean and bold against the blackness of space. This clarity makes the far side feel both intimate and infinite, like an untouched sculpture carved from light and stone. And just beyond these jagged contours lie places where sunlight barely finds its way, regions that hold the moon's most fragile shadows. Fact 40. The place where sunlight barely reaches. In some corners of the far side, sunlight slips across the landscape so gently that it feels more like a whisper than illumination. Deep craters and steep ridges create pockets where the sun's rays arrive only at the slightest angle, touching the ground for mere moments each lunar day. These half-lit regions spend most of their time in a muted twilight, resting in cool tones of gray and silver. When dawn finally arrives, light drips slowly down vertical walls, tracing their contours like soft brushstrokes. These half-shadowed pockets are reminders of how the moon's ruggedness shapes every experience of light. Here, day and night blur softly, creating a place where time feels stretched and unhurried. The far side holds these tender, dim reaches with a quiet grace. And beyond these shy-lit areas lie craters whose rims stand sharp and ancient, holding the memory of impacts from long ago. Fact 41. The crisp rims of ancient wounds. Because the moon has no wind or rain to erode its features, the rims of far-side craters remain strikingly crisp. Their edges appear almost freshly carved, as though the impacts happened yesterday rather than billions of years ago. Sunlight skims their tops with gentle precision, leaving long, delicate shadows that glide deep into their interiors. Each crater rim is a ring of frozen time, holding stories of distant collisions that shaped the lunar surface in an age when the solar system was young and restless. Walking along such a rim would feel like journeying across the boundary between past and present. Every step would echo across dust unchanged for ages, every downward glance revealing a history written in stone. And scattered among these pristine rims are vast basins that look like enormous bullseyes stamped upon the far side. Fact 42. The far side's giant bullseyes. Some of the moon's far side craters are so large and so perfectly circular that they appear like cosmic bullseyes, marked in rings of pale stone. These multi-ring basins were formed by impacts of immense scale, collisions that sent molten rock rippling outward in concentric waves. As the surface cooled, those waves froze into circles upon circles, leaving behind striking patterns that span hundreds of kilometers. From orbit, they resemble ripples on a pond that solidified in an instant, preserving their symmetry forever. These giant bullseyes are among the most breathtaking features on the far side. Their patterns tell of a moment when the moon endured forces beyond imagining, yet now they rest in utter calm, softened by gentle sunlight and the silence of deep space. And within these wide basins, rays of bright material stretch outward, delicate markings that guide us further into the far side story. Fact 43. Rays that stretch into darkness. Some craters on the moon's far side create long, bright rays that radiate outward for hundreds of miles. These rays are made of fine, light-colored material, blasted from the surface during an impact, then scattered across the rugged terrain like delicate threads of powdered moonlight. On the near side, such rays often glow softly under earthshine, but on the far side, they stand against deeper darkness, their pale streaks more pronounced, without the gentle blue glow of Earth to soften them. Under low sunlight, these rays appear almost luminous, tracing the paths of ancient explosions in patterns that feel both random and intentional. Each one is a quiet reminder of a single moment, an impact long past, that left a bright signature upon the hidden hemisphere. And deeper within some of these ray-filled craters lie towering central peaks, rising like ancient spires from the shadows. Fact 44. The crater, with a central peak, like a needle. Many lunar craters feature central peaks, lifted upward by the immense rebounding force of an impact. But on the far side, some of these peaks stand exceptionally tall, piercing the crater floors like slender stone needles. One striking example is found in the crater Tsiolkovsky, a dramatic basin with a dark lava-filled floor and a sharp central uplift that rises like a solitary mountain amid a sea of basalt. Under the long lunar day, the peak glows in pale sunlight, while its base rests in deep shadow, creating an almost surreal contrast. Without atmosphere to blur its edges, the mountain appears impossibly crisp, every slope and ridge etched with perfect clarity. It stands as a monument to the forces that shaped it, frozen motion in the stillness of space. And surrounding these peaks, silence lingers as the only companion, filling every hollow and ridge. Fact 45. The silence that fills every hollow. On the moon's far side, silence takes on a depth unlike anything found on Earth. With no air to carry sound, every crater, valley, and plain exists in perfect stillness. Even your own footsteps would feel strangely muted, vibrations traveling only through your suit and the ground beneath you. In this soundless world, each hollow holds its quiet like a delicate treasure. Shadows deepen that silence, pooling softly along crater floors and collecting in the grooves of ancient ridges. This absolute quiet creates a sense of timelessness, as though the landscape is suspended in a perpetual pause. Nothing stirs except the slow shift of sunlight across the terrain. Every crater feels like a whispered echo of the past, held in a world that listens but never speaks. And from this silence emerges a delicate artistry, craters overlapping like petals on a lunar flower. Fact 46. Craters that overlap like petals. Across the far side, countless craters lie gently atop one another, forming delicate patterns that resemble overlapping petals in a celestial garden. Each new impact carved its mark into a surface already shaped by earlier blows, creating layered circles that blend into one another with quiet complexity. Some craters touch only at their rims, while others nestle partially within larger basins, like smaller blooms sheltered by older, wider ones. In the long lunar dawn, these overlapping rings catch the light in cascading steps, bright rims shining first, then deeper floors glowing softly moments later. The effect is almost floral, a frozen bouquet crafted by time rather than life. No wind ever scattered these patterns. No rain ever washed them away. They remain exactly where the universe set them. And scattered across these ancient petals lies dust that never quite settles, drifting upward in ways that feel almost magical. Fact 47. The dust that never settles. Lunar dust, called regolith, behaves unlike any dust on Earth. It is so fine that it resembles powdered glass, yet each tiny grain is jagged, sharp, and clingy because it has never been smoothed by wind or water. On the far side, in the crisp vacuum, sunlight causes these grains to become electrically charged. They sometimes lift from the surface in gentle arcs, floating for brief moments before settling again. This soft, silent dance is called electrostatic lofting. Imagine dust that seems to breathe, rising ever so slightly at lunar sunrise, hovering just above the ground, then drifting back down as the day continues. Astronauts have never walked on the far side to witness this glow firsthand, but spacecraft instruments suggest it happens with delicate regularity. And beneath that drifting layer lies a deeper record, a blanket of history that preserves every moment the moon has endured. Fact 48. Regolith, that records every footstep. On the moon's far side, the regolith forms a thick ancient archive of impacts, cosmic particles, and quiet settling. Every grain tells a story of where it has been, what struck nearby, and how sunlight shaped it over ages. Because there is no atmosphere, no rain, and no flowing water, this dust never washes away. It simply collects, layer upon layer, holding on to the past with gentle persistence. If a traveler were to walk across the far side, their footprints could remain for millions of years, undisturbed and perfectly preserved. Each step would leave a small impression in this ancient powder, a temporary mark in a place that rarely changes. Even the smallest disturbance would be written into this record, held in place by the moon's unyielding calm. And beneath that soft blanket lie craters that have faced the universe without ever once turning toward Earth. Fact 49. The craters that face no Earth. On the far side of the moon, every crater looks out into deep space rather than toward our home. These silent basins have never seen Earthrise, never felt the soft blue glow that brightens the near side's long nights. Instead, they live beneath the pure light of the sun and the cold gleam of distant stars. Their shadows stretch without interruption, untouched by any reflected glow from Earth's oceans or clouds. To stand within one of these craters would be to step into a world entirely separate from our familiar sky. The horizon would hold only darkness and the slow arc of sunlight as it moves across the hidden hemisphere. Each crater floor is a quiet sanctuary, shaped by impacts long ago, but preserved in perfect stillness. And in this airless quiet, temperatures shift with breathtaking extremes, changes that give the far side its own distinct rhythm of warmth and cold. Fact 50. Colder than the near side, nose. Because the far side receives no comforting earthshine to soften the night, its temperatures plunge even lower than those of the near side. During the long lunar night, which lasts nearly 14 Earth days, its surface grows unimaginably cold, dropping to around 170 degrees. With no atmosphere to hold warmth, the heat radiates away into space, leaving the terrain in a deep, serene chill. When the sun finally returns, it warms the ground slowly. But the far side often remains cooler overall because of its rugged terrain. Steep shadows cling to valleys and crater floors, keeping them cold long after nearby peaks have begun to glow. The result is a landscape with a subtle, icy stillness, quiet, patient, and profoundly calm. And as the far side cycles through these vast temperature swings, it experiences a day unlike anything we know on Earth. Fact 51. Nights that last. 2 Earth weeks. One of the moon's most enchanting rhythms is its long day-night cycle. A single lunar night lasts nearly 14 Earth days, followed by a sunrise that crawls across the land in a slow, golden drift. On the far side, this extended darkness deepens the sense of solitude. Craters fill with shadows that remain for days, and high ridges stand silhouetted against a star-filled sky that never shifts with weather or wind. When dawn finally arrives, it feels like a revelation. Sunlight creeping over distant peaks, slipping into valleys, and gradually warming a world that has rested in cold silence for weeks. This unhurried transition makes the far side feel dreamlike, as though time stretches and softens with each phase. And as the sun rises higher, its light sharpens, preparing to reveal how differently it illuminates the far side's craters and ridges. Fact 52. Light that comes at a sharper angle. On the far side of the moon, sunlight often arrives at steeper, more delicate angles than on the near side. The rugged terrain, filled with high ridges, deep basins, and steep crater walls, creates a landscape where dawn filters in slowly and unevenly. As the sun rises, its light grazes the tops of mountains first, leaving valleys below in lingering twilight. This gentle slant of light gives the far side a textured radiance, as though the sun were brushing each ridge with careful strokes. Because there is no atmosphere to scatter light, every sunbeam falls clean and precise. Shadows form strong, crisp lines, stretching long and narrow before shrinking into sharp outlines at lunar midday. The effect is mesmerizing, a world shaped entirely by the quiet geometry of illumination. And with this pure light comes something else, the constant, hushed drizzle of particles from the sun. Fact 53. The quiet storm of solar particles. Across the moon's far side, a steady shower of solar particles drifts down from the sun. Without an atmosphere or magnetic field to shield it, the surface is exposed to a gentle storm of charged particles, tiny fragments of the solar wind that move silently across the airless sky. They strike the dust, charging it electrically, sometimes lifting grains into brief floating arcs. These particles also seep into the top layers of the regolith, creating subtle chemical changes over billions of years. Though invisible and quiet, this constant particle rain shapes the moon's surface in delicate ways. It darkens some minerals, bleaches others, and slowly alters the electrical behavior of the dust. On the far side, which lacks Earth's magnetic interference, the effect is even more pronounced. And as the day shifts again, those particles give way to the far side's sweeping temperature dance, a cycle driven entirely by sun and shadow. Fact 54. Temperatures that swing like tides. Because the moon has no air to hold warmth, its temperature swings are dramatic, especially on the hidden side. In sunlight, the surface can climb to around 120 degrees C, hot enough to warm stone into a slow, silent radiance. But when night falls, the heat escapes freely into space, and the land chills to deep crystalline cold. These swings create a rhythm unlike any weather pattern on Earth, a gentle breathing of warmth and cold that repeats every lunar day. Rocks expand subtly during the long sunlit hours, then contract as the darkness settles in, causing microscopic fractures over billions of years. Even this tiny motion helps shape the moon's ancient surface. The far side, with its steep valleys and towering ridges, experiences these changes in intricate patterns, each feature warming and cooling at its own pace. And within these shifting temperatures lie pockets of shadow so quiet and cold they seem to hold their breath. Fact 55. Shadows that hold their breath. On the far side of the moon, shadows behave with a kind of quiet intention. Because there is no atmosphere to scatter light, darkness gathers sharply wherever sunlight cannot reach. In craters and along steep ridges, these shadows linger for days at a time, still, chilled, and unmoving. They seem to hold their breath as the sun inches across the sky, waiting for its slow return. Some shadows stretch thin at dawn, then deepen again as the sun drifts behind nearby peaks. These pools of darkness are not empty. They are full of the moon's ancient history. Dust has settled into them for billions of years, untouched and unshaken. Standing near one, you might feel a strange sense of timelessness, as though the shadow itself remembers every moment since the moon cooled. And beyond these deep shades lies the strange dance of sunlight and electricity that makes the dust come alive. Fact 56. How dust charges under sunlight. When sunlight touches the moon's surface, its energy knocks electrons free from tiny grains of dust. This creates a gentle electrical charge, causing some particles to lift and hover just above the ground. It is a quiet, invisible ballet. Dust rising slowly, floating for moments, then drifting back down like the faintest whisper of snowfall. On the far side, without Earth's magnetosphere to modulate this effect, the charging can be even more pronounced. This electrostatic lift may contribute to a subtle glow seen at the edges of lunar dawn and dusk, an ethereal shimmer of dust suspended above the surface. Though no astronaut has yet walked on the far side to witness this, instruments hint at a faint luminosity that comes and goes with the sun's rising energy. And in the stillness beneath that soft glow, the far side's loneliness becomes even more profound, an airless quiet unlike anything on Earth. Fact 57. The airless stillness of the hidden side. The far side of the moon exists in perfect vacuum, where not even a single breeze moves across the land. Without air, there is no sound, no rustling, no whisper of motion. Everything sits in absolute stillness. Footsteps would leave crisp impressions in the dust, unblurred by weather. Even heat moves slowly through the solid rock, unmoderated by air's gentle currents. This airless quiet intensifies the feeling of solitude on the far side. Craters rest silently beneath the sun, their shadows undisturbed. Ridges stand like statues against the dark sky. In this environment, time feels stretched, softened, as if the landscape is eternally pausing between moments. And lying across this breathless terrain is the border between day and night, a sharp line that moves with unwavering precision. Fact 58. The sharp line between day and night. On the moon's far side, sunrise and sunset aren't sudden shifts of color, but slow, deliberate changes marked by a boundary called the terminator. This line between light and shadow is razor sharp, slicing across mountains and valleys with perfect clarity. Because there's no atmosphere to blur the edges, the terminator moves like a quiet tide of illumination, revealing peaks one by one while valleys remain tucked in darkness. At dawn, the land seems to awaken in stages. First, the highest summits glow with pale gold. Then the light slips softly downward, unveiling each ridge, each crater rim, each ancient ripple of terrain. Standing at the terminator would feel like standing on the edge of time itself. The world behind you would rest in cold night, while the world ahead would slowly brighten into silent day. And once the darkness finally releases its hold, even the smallest particles begin to whisper with light. Fact 59. The glow of Earthshine. That never comes. On the near side of the moon, even during lunar night, Earthshine provides a gentle glow, a soft, bluish reflection cast from our planet's bright clouds and oceans. But on the far side, this comforting radiance never touches the surface. When night falls there, it is complete and absolute. The land rests in true darkness, illuminated only by faint starlight and the distant brilliance of the sun's reflections off nearby ridges. This absence of earthshine creates a profoundly serene midnight. Shadows become deeper, and crater floors seem to blend seamlessly into the star-filled sky. For billions of years, the far side has known only this pure night, untouched by the comforting light of the planet that shaped it. And in that perfect darkness, astronomers see a rare gift: silence, not just in sound, but in radio waves as well. Fact 60. Listening to the far side's radio. Silence. Because the moon blocks signals from Earth, its far side is one of the quietest places in the solar system from a radio perspective. No human broadcasts reach these hidden plains. No chatter from satellites. No hum from cities. No static from storms. The far side offers a natural shield, a sanctuary where delicate cosmic radio waves arrive unspoiled from distant galaxies and ancient stars. Scientists dream of placing observatories here, listening to murmurs from the universe's earliest ages. The far side's silence is so complete that even the faintest whispers from deep space could be heard clearly, like echoes from the dawn of time. In this pristine quiet, the moon's hidden hemisphere becomes not just a landscape, but a listening chamber for the universe. And beyond this oasis of silence, the far side story continues with the spacecraft that first glimpsed its mysterious face. Fact 61. The first probes to glimpse the hidden side. For centuries, humans wondered what the moon's far side looked like. Its hidden face remained entirely mysterious, imagined in myths, painted in stories, but never truly seen. That changed in 1959, when the Soviet spacecraft Luna 3 became the first probe to fly around the moon and photograph its far side. The images it returned were faint, grainy, and ghost-like, yet they were enough to reveal a world unlike the near side, rugged, cratered, and almost completely free of dark Maria. These first photographs were a quiet revelation. Even through their haziness, they unveiled the moon's true dual nature, showing humanity that half of our closest neighbor was a place of pale highlands and untouched ancient scars. And from that first glimpse grew a curiosity that inspired decades of lunar exploration, each mission mapping the hidden hemisphere with greater clarity. Fact 62. How we mapped it from orbit. As technology evolved, orbiting spacecraft began to circle the moon with precise instruments capable of capturing far more detailed images than Luna 3 ever could. Missions like Lunar Orbiter, Clementine, and Lunar Reconnaissance Orbiter swept over the far side hundreds of times, photographing its mountains, basins, and craters in exquisite clarity. Laser altimeters traced its topography with millimeter precision, revealing the true depth of ancient basins and the height of towering ridges. These maps transformed the far side from a mysterious silhouette into a meticulously charted world. They allowed scientists to understand its structure, its geological history, and the differences between its rugged terrain and the smoother expanses of the near side. Through the silence of space, these orbiters quietly unveiled the details of a landscape that Earthbound eyes could never see. And among their discoveries was the source of the first clear historic image ever returned from the far side. Fact 63. The Soviet craft that first returned a picture. The honor of revealing the far side's face to humanity belongs to the Soviet spacecraft, Luna 3. Launched during the early years of space exploration, it carried a simple film camera, primitive by today's standards, yet groundbreaking for its time. As Luna 3 swung around the far side, it captured images and developed the film inside its small, pressurized chamber. It then scanned the film and transmitted the pictures back to Earth through radio signals. The result was a series of ghostly photographs that changed human understanding forever. Though blurry, they showed a land dominated by highlands rather than lava plains, with craters overlapping in intricate patterns. These first images helped scientists piece together the moon's asymmetrical history. And from those initial glimpses, the door to the far side opened wider, inviting future missions to explore its hidden terrain more deeply. Fact 64. The American missions that followed. After the Soviet Union's earliest glimpses of the hidden hemisphere, American missions took up the task of mapping the far side with growing precision. During the 1960s, NASA's lunar orbiter missions circled the moon repeatedly, capturing clearer, smoother images than ever before. Their cameras revealed details that had once been little more than ghostly smudges, sharp crater rims, basin outlines, and highland textures. Each orbit peeled back another layer of mystery, turning the far side from speculation into certainty. These missions helped planners choose safe landing sites for the Apollo program, even though astronauts would never walk on the far side. Their work built the foundation for the detailed maps we rely on today, transforming distant shadows into a familiar landscape. And with each new photograph came the realization that the far side was far more complex and far more beautiful than early images had suggested. Fact 65. Laser eyes in lunar orbit. As spacecraft technology advanced, orbiters were equipped not just with cameras, but with laser altimeters, precision instruments that measured distance by bouncing light off the surface. These laser eyes traced the far side's contours with astonishing accuracy, mapping elevation changes down to the smallest rises and dips. Instead of guessing at the shapes of basins and mountains, scientists could now see them in three-dimensional detail. Laser altimetry revealed deep troughs, subtle ridges buried beneath dust, and the full dramatic depth of the South Pole Aitken Basin. By compiling millions of distance measurements, scientists built digital models of the far side, models so precise that every ridge, crater floor, and cliff can now be studied from afar. This technology turned the far side into a world as real and tangible as any landscape on Earth, even though no human has yet stood upon its soil. And with these new tools, humanity prepared for the next great chapter of exploration, one led by a different spacefaring nation. Fact 66. China's far side pioneers. In the 21st century, China stepped into lunar exploration with a quiet determination, sending a series of probes under the Chang'e program. Among their achievements, one stands out as truly historic, becoming the first nation to land a spacecraft softly on the moon's far side. But reaching that hidden hemisphere required more than courage. It required innovation. Because the far side is shielded from Earth's radio signals, communication would have been impossible without a relay satellite placed in a special orbit behind the moon. China launched Queqiao, a satellite positioned at a gravitational sweet spot called the Earth-Moon L2 point, where it can relay signals steadily. It became the gentle voice that allowed Chang'e 4 to touch down safely in the far side's quiet landscape. And this landing marked a peaceful turning point, showing that even the moon's most hidden places could welcome visitors with patience and grace. Fact 67. Chang'e 4's historic landing. In January 2019, China's Chang'e 4 spacecraft became the first human-made object to achieve a soft landing on the moon's far side. It touched down within the von Karman crater, a serene basin nestled inside the vast South Pole Aitken region. This moment marked a quiet milestone in space exploration, one achieved not with spectacle, but with patient preparation and deep respect for the moon's hidden terrain. Chang'e 4 carried a small rover, U-22, which gently rolled down a ramp and made slow, deliberate tracks across a landscape no human eyes had ever seen up close. The far side greeted this new visitor with complete silence, just as it has greeted every impact and sunrise for billions of years. In each photograph the rover sent back revealed a world of pale stones, sharp shadows, and ancient dust. This landing opened the door to scientific discoveries that could only be made in the far side's protected calm. Fact 68. The relay satellites that make it possible. Because the moon blocks direct radio communication between Earth and its far side, any mission that hopes to land there must rely on a relay satellite. China's Queqiao satellite, placed in a halo orbit around the Earth-Moon L2 point, acts as a quiet bridge between worlds. From this vantage point, it can see both Earth and the far side simultaneously, receiving signals from the rover and sending them onward across space. This gentle choreography of communication makes the far side accessible in a way it never was before. Without such a satellite, landers would sit in complete isolation, unable to share their findings. Queqiao turns the far side silence into a channel through which discoveries can slowly flow, just as moonlight fills a dark room with soft, patient illumination. Through this relay, humanity maintains a delicate connection to a place that has always been hidden from direct view. And one of the greatest gifts of this connection is access to a realm of perfect radio quiet. Fact 69. Listening to the far side's radio silence. The moon's hidden hemisphere is shielded from Earth's constant storm of radio signals. No broadcasts from human technology reach these lands. No satellite transmissions, no city noise, no atmospheric static. It is a realm of pure, unbroken silence, the quietest natural radio environment in the inner solar system. For scientists seeking to study the faint whispers of the early universe, this silence is priceless. A radio telescope placed on the far side could detect signals older than galaxies, carrying information from the cosmic dawn. These signals are so delicate that even the slightest interference from Earth would drown them out. But on the far side, protected by the moon's solid body, they can arrive unspoiled, drifting gently across millions of years to reach an untouched surface. This perfect quiet makes the far side not just a place to observe, but a place to listen, deeply, patiently, and with wonder. And with each whisper heard, curiosity turns toward what other mysteries this hidden world might reveal. Fact 70. Telescopes. That dream of darker skies. Astronomers often imagine placing telescopes on the moon's far side, where the skies are darker and more pristine than almost anywhere in the inner solar system. Without an atmosphere, stars do not twinkle. They burn steady and sharp, their light untouched by shifting air. And with Earth forever hidden below the horizon, no artificial glow rises to pollute the night. It is a sky that belongs solely to the stars, untouched by human activity. In this timeless darkness, a telescope could peer deeper into the universe's past, catching gentle traces of galaxies forming when the cosmos was still young. Such instruments could listen to frequencies that Earth's noisy environment overwhelms, revealing ancient signals carried across billions of years. The far side's night is not just dark, it is pure, serene, and waiting. And beneath that infinite quiet lies a surface rich with unusual minerals and mysterious compositions. Fact 71. The far side's surprising composition. When scientists began studying samples and remote measurements from the far side, they discovered that its crust held a different blend of minerals than the near side. The highlands here contain more anorthosite, pale, reflective rock formed from the moon's earliest crust. This creates the far side's characteristic brightness, giving it a ghostly shimmer in the sunlight. In some regions, deep impacts have exposed materials from the lunar mantle, offering a rare glimpse into layers usually hidden far below. These compositions hint at differences in the moon's cooling process, suggesting that heat and molten rock accumulated unevenly early on. The near side stayed warm longer, while the far side hardened quickly, locking its minerals into place before volcanic flows could reshape them. Each mineral grain is a tiny piece of the moon's ancient memory, held in stone that has not changed for billions of years. And from these chemical clues emerges one of the far side's most enduring mysteries: why its crust grew thicker in the first place. Fact 72. Why its crust grew thick. The far side's unusually thick crust has puzzled scientists for decades. One leading explanation is a quiet, elegant process called asymmetric heating. In the moon's earliest days, radioactive elements capable of producing heat were not evenly spread. They gathered more densely on the near side, warming it from within. The far side, receiving fewer of these elements, cooled faster and solidified sooner. As the crust thickened, it became increasingly resistant to volcanic activity. Lava that once welled up through the near side could rarely find its way through the far side's rigid shell. This early divergence created the stark contrast we see today: smooth, dark plains on one face and rugged, ancient highlands on the other. This thick crust became the far side's defining trait, shaping its mountains, its craters, and its soul. And beneath that ancient shell lie the scars of bombardments that reveal the early history of the entire solar system. Fact 73. clues to early solar system bombardment. The moon's far side preserves some of the clearest evidence of the early solar system's heavy bombardment, a time when countless fragments of rock and ice roamed freely, colliding with planets and moons in a quiet, relentless rain. Because the far side's crust hardened early and lacked the smoothing influence of volcanic flows, each impact left a sharp, lasting record. These ancient craters, layered one atop another, act like chapters in a cosmic diary. By studying their sizes, patterns, and depths, scientists can trace the rhythm of impacts over billions of years. The far side surface becomes a timeline carved in stone, revealing when collisions were most common and how the young solar system slowly settled into calm. And within these ancient scars lies evidence of volcanic stirrings that never quite reached the surface. Fact 74. Hidden volcanoes that never broke through. Beneath the far side's thick and stubborn crust, there is evidence that magma once tried to rise toward the surface. But unlike on the near side, where lava spread into vast plains, these far side magma reservoirs were trapped deep below. They cooled slowly underground, forming intrusive rocks, solidified chambers of molten stone that never erupted. These hidden volcanoes left subtle signatures, faint distortions in local gravity, small variations in mineral composition, and gentle bulges in the surface that hint at ancient activity. They tell a quiet story of a world where fire existed beneath the crust but could not escape, stilled by the far side's enduring strength. In these silent, imprisoned magma chambers lies a geological whisper, one that only deep space instruments can hear. And surrounding these buried features is a material formed from the heat of impacts, the strange glassy melt created by colossal collisions. Fact 75. The puzzle of impact. Melt. When a large meteor strikes the moon, the force of the impact is so immense that it melts rock instantly, creating pools of liquid stone. On the far side, where many of the greatest impacts occurred, these melts formed glassy surfaces that cooled into smooth patches within larger, rugged craters. Over time, some of these impact melt regions solidified into hardened sheets, while others were buried beneath later layers of dust and debris. The texture of impact melt is unique, glassy, smooth, and subtly reflective. Under the low lunar sun, these surfaces gleam faintly, like frozen windows in a world of stone. Scientists study them to learn how violent each impact was and what conditions prevailed in the early solar system. These patches of frozen fire lie quietly in the far side silence, holding the memory of moments when the moon was struck with unimaginable force. And beneath those hardened pools, mysteries continue. Strange swirls and patterns that defy easy explanation. Fact 76. The strange swirls. Beneath the surface, scattered across the moon, including parts of the far side, are faint, ghost-like patterns called lunar swirls. Delicate, looping shapes that twist across the surface like pale brushstrokes. From orbit, they look almost like traces of wind, though no wind has ever touched the moon. These swirls are brighter than their surroundings, smooth and mysterious, with no clear geological explanation lying on the surface itself. Scientists believe they may be linked to magnetic anomalies beneath the crust, patches of magnetized rock left behind by ancient activity or unusual impacts. These magnetic fields may deflect solar particles, preserving the surface from darkening and leaving behind bright, graceful patterns. To gaze at these swirls is to glimpse a kind of lunar calligraphy written across a world that knows no weather. And where these magnetic puzzles exist, so too do pockets of ancient magnetism frozen deep in stone. Fact 77. Magnetic patches frozen in stone. Though the moon has no global magnetic field today, fragments of magnetism remain locked in certain rocks, especially on the far side, where the crust formed early and cooled slowly. These magnetic patches suggest that the moon once had a molten, active core capable of generating magnetic fields, or that immense impacts briefly created powerful currents in the young crust. Over billions of years, these magnetic memories hardened into the surface like invisible signatures. They do not shift or fade because nothing stirs the ground. Instead, they lie quietly beneath the dust, detectable only by sensitive instruments. This ancient magnetism helps scientists piece together the moon's interior history, its cooling, its early dynamism, and the quieting of its heart. These frozen fields hint at a world that once held more heat, more movement, more internal breath. And from the presence of these magnetic remnants, scientists look further inward, toward what the moon's hidden side can teach us about its deep interior. Fact 78. Heat flow that tells old stories. To understand the moon's inner workings, scientists measure heat flowing upward from its interior. On the far side, this heat flow is weaker, reflecting a crust that cooled early and thickened deeply. The measurements tell a story not of an active world, but of one that settled long ago, its internal warmth fading quietly into space. Even the shallow subsurface retains the memory of ancient cooling, storing it like a whisper beneath the dust. These faint traces of heat reveal how the moon's two hemispheres evolved differently. The near side, warmer and more active in its youth, still hides remnants of that ancient energy. The far side, ever the quiet sibling, let go of its warmth sooner, hardening into the rugged highlands we see today. By reading this thermal signature, scientists reconstruct the moon's past, one gentle clue at a time. And as the far side rests in its deep stillness, its gravity itself tells yet another chapter of this ancient story. Fact 79. What gravity reveals about its heart. Even though the far side of the moon rests in silence, its gravity tells a lively, intricate story. Orbiting spacecraft measure tiny variations in gravitational pull that hint at what lies beneath the surface. Dense regions, ancient buried impacts, and subtle differences in crust thickness. On the far side, these gravitational signatures are especially pronounced. They reveal hidden basins now filled with solidified melt, mass concentrations locked deep within the crust, and layers shaped by impacts so ancient they predate most of Earth's familiar geology. These measurements help scientists glimpse the moon's internal architecture, like reading a book by tracing the weight of its pages. Every fluctuation in gravity describes a moment from its past, a buried crater, a cooled magma pool, or the deep imprint of a colossal collision. And intertwined with these gravitational secrets is a phenomenon felt only faintly on the near side, the gentle tremors known as moonquakes. Fact 80. The moonquakes that tremble in secret. Even in its stillness, the moon is not entirely silent. Deep beneath the far side's crust, faint tremors, called moonquakes, ripple through the rock. They are far weaker than earthquakes and occur very infrequently, but they reveal that the lunar interior is not completely dormant. Some moonquakes arise from thermal changes as the crust expands in sunlight and contracts during the long, cold night. Others are triggered by tidal stresses from Earth's gravity, gently pulling and releasing the solid body of the moon. These tremors travel through the moon like soft echoes, carrying information about its inner layers. Because the far side holds thicker crust and older structures, the moonquakes that pass through it provide different clues than those on the near side, whispers from depths we cannot reach. And beyond these quiet tremors lies the future, where humans may one day walk across the far side's silver plains. Fact 81. Astronauts who may walk there first. Though no human has ever set foot on the moon's hidden hemisphere, plans for future missions often include dreams of exploring the far side. Astronauts of tomorrow may travel in sleek landers, touching down on soft regolith that has never known a human footprint. They may gaze into a sky where Earth never rises, watching instead the slow, patient motion of stars across an unchanging horizon. These explorers could set up instruments, build shelters, or study the rocks that hold the moon's oldest stories. Walking on the far side would feel like strolling through prehistory, each step pressing gently into dust that has lain undisturbed for billions of years. The silence would surround them like a blanket, and the long lunar day would give them time to work in calm, unhurried light. And as they explore, they may begin constructing something extraordinary, telescopes and observatories that harness the far side's perfect quiet. Fact 82. Telescopes in the far side silence. Imagine a telescope resting gently on the lunar far side, its instruments shielded from Earth's constant chatter. This perfect silence, it could listen to the faintest cosmic signals, whispers from galaxies forming billions of years ago, or soft radio echoes from the earliest moments after the Big Bang. Without atmospheric distortion, the stars would shine with pure clarity, each one a steady point of ancient light. A far-side observatory wouldn't just look deeper, it would listen further. Radio waves that Earth's noise would drown out could drift unimpeded to its detectors. This quiet sanctuary makes the far side one of the most promising locations in the solar system for unraveling cosmic mysteries. And beyond telescopes that gaze skyward, scientists dream of instruments that listen inward, toward frequencies that sleep in the dark. Those dreams guide us to a vision of observatories that work not with visible light, but with radio silence itself. Fact 83. Radio observatories in eternal night. The moon's far side offers something Earth can never give. A place where radio darkness reigns, uninterrupted and absolute. A radio observatory placed here could study wavelengths so delicate that even a single human broadcast on Earth would overwhelm them. With the moon blocking all terrestrial signals, the far side becomes a cradle for listening to the universe in its most ancient frequencies. Such an observatory might lie in a deep crater, where tall walls shield instruments from sunlight and temperature extremes. There, nestled in a basin of perpetual quiet, it could tune into signals dating back to the cosmic dawn, the era when the first atoms formed and the universe's earliest structures began to glow. In such a place, science becomes almost meditative. Instruments would listen, not look, capturing the soft hum of creation. And once these observatories exist, they may help support something even grander. The beginnings of lunar habitations sheltered from Earth's bright light. Fact 84. Bases hidden from Earthlight. If humans one day build habitats on the moon's far side, those settlements would enjoy a kind of cosmic privacy impossible anywhere else. Without Earth hanging in the sky, nights would be truly dark, ideal for astronomy, restful living, and quiet contemplation. Bases could nestle in gentle craters or along sheltered ridges, where sunlight would arrive in long, angled sweeps rather than sudden bursts. Life on the far side would follow the rhythm of the lunar day: 2 weeks of warm sunlight, 2 weeks of serene night. During the bright period, solar panels could gather energy in unbroken clarity. During the long night, astronauts might sleep beneath a flawless tapestry of stars, unfiltered by atmosphere or reflected glare. Such bases would feel like little islands of light on a sea of silence, places where human presence meets the moon's ancient calm. And from these quiet outposts, explorers could set out to uncover resources hidden deep within the far side's crust. Fact 85. Dreams of mining frozen crusts. 1. Day. Explorers may look to the moon's far side for resources buried deep within its crust, minerals forged in ancient collisions and preserved in untouched layers. The far side's rugged terrain holds clues of materials like rare metals, helium-3, and crystalline structures that formed under unique conditions. Mining here would not resemble loud, bustling operations on Earth. Instead, it would unfold slowly and quietly, shaped by the far side's long days and nights. Robotic diggers might glide across the surface on soft treads, carving shallow trenches into the dust, while astronauts guide them from sheltered bases. Each scoop of regolith would reveal fragments of history: shiny grains, glassy beads, and minerals untouched since the solar system's infancy. Extracting these resources could support future settlements or fuel deep space missions. And while these dreams slowly take shape, small machines might roam ahead, scouting the far side's untamed beauty. Fact 86. Rovers that will wander the dark future. Rovers designed for the far side will move with deliberate patience, built to survive its long nights and steep landscapes. They may roll across jagged ridges, descend into deep craters, and climb gentle slopes that have never known a human footprint. Their wheels will kick up dust older than all human civilizations combined, forming soft clouds that drift and settle in the moon's quiet gravity. Equipped with cameras, drills, and delicate sensors, these rovers will study minerals, measure radiation, and search for clues about the moon's earliest days. Each photograph they send home will carry the hush of the far side's solitude, a world where even machinery feels gentle in the absence of wind or noise. And as these rovers explore, they may discover entrances to hidden caverns below, places where astronauts could one day find shelter and mystery alike. Fact 87. Subsurface caves, yet to be explored. Beneath the moon's crust lie lava tubes, ancient tunnels carved long ago when molten rock once flowed beneath the surface. Though most are found on the near side, scientists believe similar structures may exist on the far side as well, hidden beneath layers of highland stone. These caves could stretch for miles, offering natural protection from radiation, micrometeorites, and temperature extremes. Imagine stepping inside one, the ground soft with dust, the ceiling arching in smooth curves, the airless silence growing even deeper. Within these sheltered halls, equipment could be stored safely. Telescopes could be shielded from sunlight, and future explorers could find refuge during the long lunar night. No one has entered such a cave yet, but someday its darkness may become a sanctuary for science and discovery. And tucked near the poles, deeper and colder still, lies a resource more precious than metal: frozen water waiting in shadow. Fact 88. The promise of polar water. Near the moon's south pole, where the far side stretches into deep, ancient shadow, lie craters whose floors have not seen sunlight in billions of years. These permanently shadowed regions are some of the coldest places in the solar system, chilled so deeply that even the faintest warmth cannot reach them. In these frozen pockets, scientists have detected the presence of water ice, fragile crystals preserved in eternal darkness. This frozen water holds enormous promise for future explorers. It could be melted into drinking water, split into oxygen for breathing, or transformed into hydrogen fuel for journeys farther into space. Yet the ice itself has a quiet beauty. It rests in pristine stillness, locked away in craters where time hardly moves. Imagine the first beam of light from a rover's lamp glinting across those crystals, revealing a treasure hidden since the dawn of the solar system. And from these icy shadows, curiosity travels outward, seeking clues to the moon's earliest past. Fact 89. Learning the moon's earliest secrets. The far side's ancient surface is like a vast, untouched archive. Each crater, ridge, and grain of dust holds a fragment of the moon's story, its fiery birth, its cooling crust, and the long cosmic reigns of impacts that shaped it. Scientists study the far side not only to understand the moon itself, but to peer into the early history of the entire solar system. Its craters record the rhythm of ancient bombardment, while its minerals carry signatures of deep lunar layers brought to the surface by colossal impacts. By reading these patterns, researchers can piece together how planets formed, how collisions sculpted young worlds, and how the early solar system slowly drifted toward calm. The far side becomes a canvas of clues, each one painted by time and silence. And as these secrets unfold, the far side offers something even grander, a vantage point for seeing the universe itself more clearly. Fact 90. How the far side helps us see the universe. The moon's hidden hemisphere is more than a geological wonder. It is a place where the universe can be observed with a purity unmatched anywhere near Earth. Free from radio noise, atmospheric shimmer, and the echo of human technology, the far side acts as a sanctuary for cosmic exploration. Telescopes placed here could listen to the universe's faintest whispers, signals older than stars, older than galaxies, born in the first breaths of creation. Even the simple act of looking upward would feel different here. The stars would shine with unwavering clarity, each point a perfect reflection of ancient light. Without Earth overshadowing the sky, the cosmos would stretch in an unbroken sphere around you, vast and serene. In this profound stillness, the far side becomes a bridge between human curiosity and the universe's quietest truths. And as we approach the final stretch of this journey, the far side's poetic beauty begins to shine. Its silence, its shadows, and its gentle mysteries. Fact 91. The poetry of a world we'll never see directly. Even though humans have mapped the far side of the moon with exquisite precision, we will never see it directly with our naked eyes from Earth. That unreachable quality gives the far side a quiet poetry, a sense of distance that feels almost tender. It is a world that keeps its face turned toward the deep cosmos, not out of secrecy, but simply because of a timeless gravitational rhythm. In that gentle constancy lies something beautiful, a reminder that not all wonders need to be seen to be felt. When spacecraft send images of the far side home, they reveal steep highlands, pale ridges, and craters that overlap like ancient lacework. Yet no photograph can fully capture the emotion of imagining a landscape forever facing away from us, resting in patient solitude. And as we drift deeper into this final chapter, The far side reminds us of the eternal turning that keeps its silence intact. Fact 92. The far side's eternal turn. Locked in its graceful dance with Earth, the moon always rotates at just the right pace to keep one face hidden. This eternal turn, steady, predictable, and unbroken, creates the far side's identity. While the near side watches Earth through every phase, the far side sees only the stars. It experiences no Earthrise, no reflected glow, no shifting blues or whites in its sky. Instead, it lives in a rhythm entirely its own, one guided only by sunlight and shadow. This endless repetition has continued for billions of years, longer than any mountain range on Earth has stood, longer than any ocean has existed. With each orbit, the moon renews an ancient vow. One face for Earth, one face for the universe. And within that cosmic promise lies a landscape that records time itself, etched in streaks of light and shadow like delicate writing. Fact 93. Shadows that write their own history. On the far side, shadows are storytellers. They stretch across crater rims, pooling in valleys, tracing the shapes of ancient impacts preserved so perfectly that they seem freshly carved. As the sun moves slowly across the sky, these shadows shift with exquisite patience, revealing subtle ridges, highlighting forgotten basins, and marking the quiet passing of lunar time. Each dawn and dusk, the changing shadows rewrite the scene without ever erasing what came before. They highlight sharp rims one moment and soften distant slopes the next, creating a gentle choreography of darkness and light. In a place without wind or water, shadows become the closest thing to motion, quietly painting the far side with the poetry of illumination. And as these shadows deepen and fade, they lead us into the final wonders of the moon's hidden world, places where serenity and silence linger like a lullaby. Fact 94. A hemisphere quiet enough for dreams. If you could close your eyes and step onto the far side of the moon, you would find a stillness so deep it feels almost dreamlike. With no air to carry sound and no Earth hovering overhead, the land rests in a quiet untouched by anything familiar. The stars shine with unwavering clarity, and the ground beneath your feet holds a hush older than any story told on Earth. Here, every ridge and crater seems to breathe softly, as though the landscape itself is in a state of eternal meditation. This quiet is not emptiness, it is presence, a gentle fullness, a peacefulness that wraps itself around stone and shadow, inviting the mind to drift. The far side stillness is the kind that makes thoughts slow, breath deepen, and wonder settle like soft dust. And in this vast, silent calm, one thing stands out. The stars appear unspoiled, bright, and perfect. Fact 95. The glow of stars. Unspoiled. On Earth, our night skies are softened by our atmosphere, by moisture, air currents, and scattered light. But on the far side of the moon, the stars appear with a purity we can hardly imagine. Each point of light shines sharp and unwavering, untouched by twinkling or glare. Constellations stretch across the sky with crisp precision, and faint galaxies emerge like delicate smudges of starlit dust. Without Earth's glow or human-made light, the darkness becomes a canvas where the universe paints freely. Looking upward from the far side, you might feel as though the sky is closer, as if the stars themselves are leaning gently down to keep you company. Their steady brilliance turns the lunar night into something warm and intimate, despite the cold beneath your feet. And beneath those unspoiled stars lies a horizon shaped by secrecy, a boundary that is always faced away from us. Fact 96. The horizon that hides from us. The far side's horizon never reveals Earth. No matter where you stand, how far you walk, or which ridge you climb, our planet remains forever absent. This creates a horizon unlike any other, a curve of pale stone and endless space, uninterrupted and serene. It is a boundary that turns its back to Earth, offering instead an unbroken view of the cosmos. The land rises here in gentle slopes and rugged cliffs, forming silhouettes that seem to guard the moon's ancient privacy. To gaze at this horizon is to feel a subtle shift inside yourself, a reminder that even familiar worlds can hold unreachable places. The view is both humbling and soothing, like standing at the edge of a quiet ocean and listening to its gentle breathing. And beyond this hidden horizon lies a world that watches us without ever being seen. Fact 97. A world that watches us without being seen. While we gaze at the moon's near side night after night, the far side quietly completes its endless orbit, always turned away. Yet despite its solitude, it remains part of the moon's gentle watch over Earth. As the moon circles us, its hidden hemisphere travels along, silent, steady, and unseen. In a way, the far side watches our world just as faithfully, feeling Earth's gravitational pull, responding to its tides, and joining the ancient dance that binds the two bodies together. This hidden companionship gives the far side a tender sort of presence. Though it never faces us, it shares in every phase, every eclipse, every orbit. It follows Earth's path with unbroken devotion, even if no human eye from the ground has ever directly met its gaze. And within this quiet partnership lies a deeper calm, an untouched stillness resting in every crater. Fact 98. The moon's secret companion. The moon has long been our companion in the sky, but the far side feels like a companion within a companion, a hidden friend who keeps its own counsel. Its landscapes are older, its surface more rugged, its craters more densely packed. It holds the moon's truest memories, from its earliest glaciers of molten rock to the distant impacts that shaped its soul. In its silence, the far side carries a sense of wisdom, as though it has watched the universe with a quieter, more contemplative gaze than the near side ever could. This secret companion teaches us that the moon is not just the luminous face we see, but also the unseen world behind it, its quiet heart. To understand the moon fully, we must embrace both sides, the familiar glow and the hidden shadow. And within that hidden shadow lies a kind of peace unlike any other, a stillness that waits patiently through ages. Fact 99. The stillness that waits in every crater. Every crater on the far side holds a stillness that feels almost alive. Step inside one, and the silence becomes deeper, the shadows cooler, the light softer. The curved walls rise like ancient amphitheaters, but no sound will ever echo there. Dust coats everything in a fine, untouched layer, recording each moment that has passed since the crater formed. Moments measured, not in years, but in eons. As the sun sweeps slowly across the sky, shadows slide in graceful arcs along the crater floor, revealing hidden ridges and smooth patches of ancient melt. In the long lunar night, these hollows become pools of darkness where the stars shine brighter overhead. This stillness is not simply absence, it is presence, a serene, patient calm that has endured billions of years without breaking. And in that timeless peace lies one final truth. The hidden side mirrors our own sense of wonder. Fact 100. The hidden side that mirrors our curiosity. The far side of the moon is a mirror for the quiet questions we carry within ourselves. It reminds us that even familiar worlds hold mysteries just beyond view, places shaped by silence, shadow, and time. Though we cannot see it from Earth, we feel its presence in every lunar phase. Its rugged highlands, untouched craters, and patient horizons reflect the beauty of the unknown, inviting us to wonder gently rather than seek fast answers. In its stillness, the far side teaches us that not all secrets are meant to be solved. Some exist simply to soothe our imagination. And as the moon circles us, the hidden side travels with us, whispering softly of worlds that wait in silence. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. Sweet dreams, and see you among the stars.